Today the topic of my lecture is belt. In this lecture we will try to tell you what is belt, what are pulleys, what are the types of pulleys and what are different types of belts, and later on after this lecture we will try to cover each belt one by one. Let's start with the belt definition. Belt is actually loop strip of flexible material which are used to transfer different things from one place to another place, or it can be used to transfer the power from one shaft to another shaft, from one mechanical element to another mechanical element, or comparatively long distance. We have studied gear. This was one gear. Let's say this was another gear. This was a tooth on one gear and this was a tooth on another gear. This is one shaft and this is another shaft. Now you can see that the distance between the two shafts between which the power is transferred is very small, but in case of belt the power is transferred between two shafts. They are relatively at longer distance, and these belts are used to mechanically link two shafts. This is the diagram of the belt. You can see this belt is made up of flexible material that can be polymer or composite, but that will be flexible. And if you see over here, let's say this is a shaft that is connected with the motor. The motor is rotating, due to which this shaft will rotate in this direction. So due to this rotation, the pulley that is mounted on this shaft will also rotate, and because of that pulley, this belt will start rotating with it, and that belt will rotate this pulley with itself, and that pulley will rotate this shaft. So you can see how the motion or the power is transferred between the two pulleys. And as I told you, it can be used to transfer the luggages as well. This is a conveyor belt where this luggage is transferred from this point towards this point. These days this conveyor belt mechanism is largely used in the manufacturing industries to transfer the raw material or work in process from one point to another point. It is used to transfer the rotational motion from one mechanical element to another mechanical element. Mechanical element can be shaft. Let's see, we have two shafts upon which we have mounted two pulleys. This is how a belt is wrapped around them. If this is a driver pulley, so due to its rotation it will rotate the belt with itself as well, and as a result this mechanical element, that is shaft, will also rotate. So you can see this was a rotational motion. So this rotational motion is transferred to this shaft, so it is used to transmit rotational motion as well. It is replacement for the gears and other relatively rigid power transmission devices. You know that gear can be made up of materials like steel, but this belt can be made up of polymer, or it can be composite of polymer and metal, which will be relatively flexible as compared to the gears. And gears, since are made up of steel or other costly materials, so as compared to the gears, belts are relatively cheaper, so it reduces the cost of the system as well. And it is multi-point contact. Earlier I told you about two gears. Let's say these are two gears. This is the tooth on one gear and this is the tooth on another gear. The contact between these two gears will be a point contact. A point on the tooths will come in contact with each other, and due to that point contact, motion will be transferred. Because of that, it will be noisy as well. But here in this case, this belt is multi-point contact. Helical gears can also be multi-contact, but at the start it will be point contact, then gradually the contact will start increasing to a line contact. So belt is multi-point contact. You know that whenever there is a mechanical element or machine, there will be shocks, there will be vibrations. For example, in case of the gears, this was one tooth and this was another tooth. If this is rotating like this, as soon as this teeth come in contact with this teeth, through this point contact there will be a shock load on this teeth, and there will be vibrations as well in this. So in case of this belt, since there is a constant multi-point contact, so there will be no shock, and vibration will also be absorbed since this is made up of a flexible material. Because of that, the life of the machine will be greater as compared to the gear. Then there is another important thing that should be considered, that is slip. Now you should be worried about that if this pulley is rotating, then how this belt is going to rotate with this pulley. The main responsible agent for this is friction force. When this rotate, there will be friction between the belt and between the pulley. So due to that friction, the belt will also rotate with the pulley, and when that belt come over here, since this belt is rotating, due to the friction again it will rotate this pulley with itself. But if this friction is not mature enough that the whole motion of this pulley is transferred to this belt, then there will be slip. This belt will slip over this pulley. For example, pulley is going with 1 meter per second speed. If there is a slip, then pulley will rotate with 0.9 meter per second speed. So this is important thing that should be considered. Because of that slip, there will be difference in the velocities of the belt and pulley, and there will be no constant velocity ratio. There will be a creep as well in this belt, and as soon as there is a crack appeared in this belt, since that crack or scratch can get enlarged, so you should directly replace that belt. Now another thing, that is one side of the belt will be tight and one side will be slack. It is actually, you know, that when this pulley rotates in this direction, it will start forcing this belt in this direction, and since this pulley is static, so it will start exert force in this direction. So both the forces are in opposite direction, so there will be tension in the belt. If you come over to this point, you can see the pulley is rotating in this direction, and similarly the belt is also rotating in this direction. So this pulley will exert force on the belt in this direction, and due to these two forces, this one is rotating, so it will start forcing this belt in this direction. You can see if this is F3 and this one is F4, both are in same direction. F4 here there is tension 1, and at this point there is tension 2. So tension 1 will be greater than tension 2. Since tension 1 is greater, so at this point this side will be tight and this side will be slightly slack, like this. This is the apparent sag in the belt. Now I'm going to count you the importance of the sag. Let's say you have this pulley and you start exerting a force of 2 Newton on this point and 2 Newton on this point through a belt. Then you know that if you transfer this force over here, it will be in this direction, and this force when transferred to this point, it will be in this direction. Both have the same magnitude, so they will get cancelled out each other. So this pulley is not going to rotate because both of the forces are equal to each other. But if you have 2 Newton over here and 1 Newton over here, then what will happen is that there is difference between T2 and T1, so this pulley is going to rotate. So for the transfer of the motion, the difference in the tension is important, and when there is a difference in the tension, there will be sag. So when there is a sag, there will be difference in the tension and there will be a transfer of motion between the two shafts. So this is one importance of the sag. Another important thing is that for the transfer of motion or of power, the friction is important, and friction can be increased by increasing the frictional area. In case of no sag, the belt will be straight. So let's say at this point the contact between the belt and the pulley ends. But if there is a slack, it will be like this. So the contact will end at this position. So due to the slack, there will be increased in the fractional area, and because of that the motion or the power will be transferred very easily. So these are the two importance of the slack. Let's talk about the types of pulleys. There can be different types of pulley: driver pulley and the driven pulley. Driver pulley will be that pulley that will be connected with the motion source, and driven pulley will be that pulley that will be connected with that shaft to which the motion will be transferred. And on the shaft to which the motion will be transferred, we can connect two types of pulley. One will be this driven pulley and another one will be loose pulley. Loose pulley is the pulley that is used to obtain clutch effect. Now how that clutch effect will be obtained, let's talk about that. Let's see, we have a shaft and we have a pulley. We have mounted the pulley over the shaft like this, but let's say there is no joint between these two things. Now if the shaft rotates, this pulley is not going to rotate, and if this pulley is rotating, the shaft will not rotate, it will be still. This is how a loose pulley will be. Now if we want it to be a driven pulley, what we will have to do is to groove this shaft like this. We have a groove over here in this shaft. We will make a groove on this pulley as well like this, and we will connect these two like this. And since still there is no joint between the two, we can use a coupling key to be inserted over here. Let's say this is a coupling key, we insert it over here. After insertion, let's say when this shaft rotates in this direction, it will exert a force on this coupling key to rotate with itself, and in return it will exert a force on this pulley to rotate with it. So the pulley will rotate, and if this pulley is rotating in this direction, it will exert a force on this coupling key, which in turn will exert a force on this shaft, so it will rotate. So if we want a motion to be transferred from the shaft to the pulley, we should insert a coupling key in the groove, or we should have a permanent joint between the two. If there is no joint between the pulley and the shaft, then one element will rotate but another one will not rotate. So here this is the case where there is no joint between the shaft and the pulley like this. We can add bearings as well at this point. When one element will be rotating, another will not be rotating. So what will happen if we have this type of connection over here? This type of connection is called loose pulley. If we want this motor or this driver shaft to be rotating, but we don't want this the driven shaft to rotate, we want it to be static, then what we can do is to take a shift fork. We will shift this belt over here and this belt over here to this pulley, so this will rotate and this belt will also rotate, but this will not rotate. So this is one type of pulley. This one is another type of pulley where we will obtain different type of rotational motion at the driven pulley. For example, this is the driver pulley and this is the driven pulley. Now if we take this fork and try to move this belt over here and over here, so the belt will be at this point. For both the pulleys, if we consider there is no slip, V1 will be equal to V2, this one will be equal to R1 into omega 1, that is equal to omega 2 and to R2. So R1 divided by R2 will be equal to omega 2 divided by omega 1. You can see the ratio of the rotational motion is equal to the ratio of their radiuses or diameters. Now if you move it over here, then this R1 and R2 or D1 and D2 will get changed. So due to omega 1 and omega 2 is going to change, so we can get different types of rotational motion. Here another important thing I want to tell you is that these two type of pulleys can be used for the flat belts. Later on I will tell you what is flat belt. Then we have another type of pulley that is same like this, but here we have grooved it. You can see the grooves over here. The diameter is decreasing with the each groove. Through this type of pulley we can obtain different rotational motion. We can use these pulleys for V-belts and round belts. Then let's talk about shaft alignment. Shaft can be parallel to each other, as in this case. For example, this is one shaft, this is another shaft. These two will be parallel to each other. The distance between these two shafts at every point will be the same. We can have another shaft alignment as well, that will be the shaft will be perpendicular to each other. You can see the 90-degree angle, but important thing that should be considered is that, for example, this is the plane of one pulley and this is the plane of another pulley. This plane is perpendicular to the screen of your mobile or of your laptop, but here if you see, this belt will be at 45-degree angle when it is leaving or entering the pulley, or mid plane to the plane of the pulley. And we can have another type of alignment as well, where there will be some angle other than 90. It can be 45, 60, or it can be any degree angle, but for that we can use other pulley as well to obtain this condition, that is the belt should be at mid plane when it is coming out or entering the pulley. Then we have geometry of the belt. It can be open geometry like this, and it can be crossed as well. It is starting from here and wrapped like this, since it is making a cross over here, so that is why it is called cross belt. This one can only be used for the flat belt. Another thing that should be considered is that when the belts are crossing each other, they should not be in contact. They should be slightly away from each other. And another important thing is that if you see over here, let's say this is the belt that is wrapped through this pulley. If you see over here, this is one face, this is another face of this belt. As it moves to this point, it will be this face and this face is the same, so there is only one face that is in contact with the pulley. So to improve the friction, we will have to apply fractional material, but in this case we will have to apply it to only one face, that is to the lower face. And here in this case, let's say if this was the belt, at this point this is the face where there is contact between the pulleys, but when it moves to this pulley, only this face will be in contact with the pulley. So you will have to apply the fractional material to the both sides of the belt. Then we can have another geometry of the belt as well. We can use it like this, but this will be the case when we want the transfer of the power from one shaft to two shafts. This pulley is used to increase the tension in the belts. It is Adler pulley. So these are different possible geometries. Then we have different types of belts. First one is flat belt. This is a flat belt. If you cut this flat belt and if you see its cross section will be rectangular like this, so that is why it is called flat. And round belt is a type of belt whose cross section will be round. So this is the example, and you can see we have shown you the interior of the belt as well. These are metallic wire that can be steel to increase the strength of the belt. Then we have V-belt. V-belt is like this. Its cross section is like this. If we increase downward, it looks like V. So that is why it is called V-belt. And then we have timing belt. Timing belt is another type of belt on which there are teeth. These teeth are used on this timing belt to remove the slip in the belt. This is table 17.1, in which we have different types of belts: flat, round, V-belt and timing belt. These are the cross sections of those belts. Except the timing belt, we have shown the side weave, the sweep of the belt. Here another thing is that if this belt get detached from each other, we can give it joint, and we can give joint to the round belt as well, but to the V and timing belt we cannot give joint. This is the thickness for the flat belt, and this is the condition for the diameter of the round belt. This is the condition for the V belt, and similarly for the timing belt, which you know that belts are wrapped around the pulleys. Let's say this is pulley 1 and this is pulley 2. You will have to wrap it around like this. Now you know that this is the center distance between the two shafts or two pulleys. There is no center distance condition for the flat belt, similarly for the round belts, but there is condition for the V belt and timing belt. There will be a certain conditions later on in other lectures. I will show you those conditions. So this is all. From here we will come up with those belts, the design of those belts, the analysis of those belts, and I will try to solve examples and problems on these belts as well.